now going to walk through two examples where we are going to revolve a region about a line y is equal to b. This is just a line that is parallel to the x-axis. We're going to find the volume of the solid obtained by rotating the region bounded by the given curves about the given line. Let's look at our first example. The first thing that you want to do is to draw each curve, and I've already done that. Here's the line y is equal to x, and here's our curve y is equal to the square root of x. The region enclosed by these two curves is this region right here. And this region is going to be revolved around the line y is equal to 1. Because the axis that this region is revolving about is parallel to the x-axis, the limit of integration is going to be in terms of x, and because there is a gap between the region and the line of rotation, we're going to have an outer radius squared minus an inner radius squared. Let's look and let's see what this radius is equal to. I'm going to draw a diagram for the outer radius, and then the inner radius will be really similar. The radius is the distance from the curve to the revolving line, so we'll label this as r, and then because our curves are y is equal to a function of x, we need to find what y is. Y is the distance from the x-axis to the curve, so let's label this as y. From this diagram, you can see that r plus y is equal to 1, and that tells us that our radius r is 1 minus y. I'm going to go ahead and highlight that because we're going to need that in a minute. If you don't want to figure out what r is each time, you can remember that there is a formula that r is equal to b minus y when the axis of rotation lies above the region. Now that we know what r is, we need to now find our two intersection points. This is going to be a and b in our formula. To do this, all we do is set the two curves equal to each other. We're going to set x equal to the square root of x. We'll square both sides, and we get x squared is equal to x, and then we'll subtract x, set that equal to 0. We can factor out an x, and this gives us that x is equal to 0 and x is equal to 1. And we're going to need this, so I'm going to go ahead and highlight that. Now we can go ahead and write down our formula. Our volume is pi times the integral from a to b, our outer radius squared minus our inner radius squared. And because our line is parallel to the x-axis, we're integrating with respect to x. Now let's find out what our equation for our outer radius is. We're integrating from 0 to 1. Our outer radius is this distance right here, and that corresponds to y is equal to x. So r is equal to 1 minus x quantity squared. And then we subtract off our inner radius. If we go back up to our diagram, this is our inner radius, and it corresponds to the curve y is equal to the square root of x. So using our formula for r, we have 1 minus the square root of x quantity squared times dx. Now all we have to do is integrate. Before we do the integration, we are going to simplify what we're integrating, and we're going to have to multiply out both terms. Just remember the formula, a minus b quantity squared is a squared minus 2ab plus b squared. This gives us 1 minus 2x plus x squared minus 1 minus 2 root x plus root x squared, which is just x. Now let's go ahead and let's pull that negative through to our last three terms. So we have 1 minus 2x plus x squared minus 1 plus 2 root x minus x. I really think it helps to break this up into 2 steps so that you don't forget to multiply that negative through to all 3 terms. Now it looks like we can simplify this before we integrate it. The 1s are going to cancel. We can combine our x's, so we have minus 3x plus x squared plus 2 root x, and I'm going to write this as 2x to the 1/2, because that makes it easier to integrate. Now let's go ahead and do our integration. This is pi times minus 3 x squared divided by 2 plus x cubed divided by 3 plus 2x to the 3/2, all divided by 3/2, and we're integrating from 0 to 1. Let's see what this gives us. If we substitute in that x is 1, we have a minus 3/2 plus 1/3. 2 divided by 3/2 is 4/3, so we have a plus 4/3, and then we let x be equal to 0, and that, of course, is 0. This is equal to pi times minus 3/2 plus 5/3. Let's get a common denominator of 6. So this is a minus 9 plus 10, which leaves us with an answer of pi divided by 6. Let's now look at our second example. In this example, we have a region that we are rotating about a line y is equal to -1, and our line lies below the region. I went ahead and graphed all 4 of these curves, and the region that we are going to be revolving is the region that is the intersection of all of these curves, and it looks like this. The first thing that we want to do is find the outer radius and the inner radius. We'll find the outer radius first, and then the inner radius will be in the same format as the outer radius. This is the outer radius. We'll mark that as r. And notice that this length is equal to y. So we can say that r minus y is equal to this distance right here, which is equal to 1. So this tells us that our radius r is equal to 1 plus y. We'll highlight that because we're going to need that. For this problem, we don't need to find our limits of integration because they're given by our 2 lines, x is equal to 1 and x is equal to 3. We can go ahead and write down our formula. Our volume is equal to pi times the integral from a to b, our outer radius squared minus our inner radius squared. We're rotating about a line that is parallel to the x-axis, so we have limits of integration in terms of x. Let's now put in what our limits are. We are going from 1 to 3. Our outer radius corresponds to our top curve, so this is going to be 1 plus 1 over x squared quantity squared. And then we're going to subtract off our inner radius. Our inner radius is actually a lot easier, and it corresponds to the curve y is equal to 0. So our inner radius is just 1 plus 0 quantity squared, and then we have our dx. Before we integrate, let's go ahead and simplify what we're integrating. We are going to multiply everything out. This gives us 1 plus 2 over x squared plus 1 over x to the 4th minus 1 dx. Our 1's cancel, and I'm going to rewrite this so it's going to make it easier for us to integrate it. 2 over x squared we're going to write as 2x to the minus 2, And then 1 over x to the 4th, we're going to write as x to the minus 4, and then we have our dx. Now we can go ahead and integrate. This is pi times 2 times x to the minus 1 divided by minus 1 plus x to the minus 3, all divided by minus 3, and x is going to go from 1 to 3. Just to make this easier, I am going to rewrite this before we plug in our limits. This is pi times minus 2 over x minus 1 all over 3x cubed, and then x goes from 1 to 3. Let's now substitute in that x is equal to 3. This gives us a minus 2/3 minus 1 all over 3 times 3 cubed, so this is just 3 to the 4th, minus, now we're going to let x be equal to 1, so this is a minus 2 minus 1/3. Let's simplify this and see what we get. This is a minus 2/3. 3 to the 4th is 9 times 9, so that's just 81. And then we have plus 2 plus 1/3. Let's combine our 1/3 and our minus 2/3. This gives us a minus 1/3 minus 1 over 81 plus 2. It looks like we need to get a common denominator of 81. I know that sounds terrible, but it won't be as bad as it looks. 3 goes into 81 27 times, so we have a minus 27. We have a minus 1, and then 2 times 81 is 162. This gives us then an answer of 134 times pi, all divided by 81. A lot of times when you do these volume problems, you don't get really nice answers.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.